Hello friends, welcome back to my channel Maths by Samit Deshmukh. In this video, we are solving example from exercise 1.4. In the last video, we have proved one important formula to find out derivative of what? Parametric function. Applying that formula, we are going to find out derivatives of what? Parametric function, and all the example from this exercise 1.4 are related with what? Parametric function. When we can say that function is parametric, if the value of our dependent and independent variable we are denoting by y and independent variable we are denoting by x. If the value of these two variable are expressed in terms of new variable, here the value of y is expressed in terms of new variable t and value of x is also expressed in terms of new variable t, then this new variable is called as parameter, and such type of functions are called as parametric function. So we have one theorem to find out its differentiation. So observe that theorem. So we have one theorem that dy upon dx is equals to, here the parameter is denoted by dt, so dy upon dt divided by dx upon dt. So this is nothing but the important theorem which we have proved in the last lecture to find out derivative of what? Parametric function. So let us apply this formula. So here in the numerator, d by dt, keep it as it is, d by dt keep it as it is, just substitute the value of y. What is the value of y? 2at. In the denominator also, d by dt keep it as it is, replace x by its value. What is the value of x? at square. So which is equal to, now we are differentiating this function with respect to t. So what is the derivative of 2a is a constant term, keep it as it is, derivative of t is equals to 1. And in the denominator, a is a constant term, keep it as it is, derivative of t square will be equal to 2t. So which is equals to, if you observe the numerator and denominator very carefully, 2 will get cancelled, even a and a will also get cancelled. So what we'll get here? 1 by t. 1 by t will be the value of what? dy by dx. In this way, applying this theorem, we have got our required value, means required value of differentiation. So hope the idea about how to apply this theorem is very clear to you. Again, applying the same theorem, we are solving second example. तो थोड़ा सा मैं स्टेप चेंज कर लूंगा, कब कौन सी मेथड यूज करना है ये भी आपको पता चलेगा. So observe, in the second example, value of x is also given, value of y is also given to us. So here differentiate, first consider the value of x. Consider x is equals to a cot theta. So differentiate it with respect to x. Differentiate with respect to, theta. We are differentiating it with respect to theta because here parameter is theta. In this example, parameter is what? T. Parameter can be denoted by any notation. So differentiate it with respect to t. So we will get dx upon d theta will be equals to, a is a constant term. What is derivative of cot theta? Will be equal to minus cosec square theta. So denoted by equation number first, we have got the value of dx by dt, dx by d theta. Now consider y. So what is the function y? Y is equals to b cosec theta. So we are differentiating it with respect to our parameter. What is the parameter? Theta. Derivative of y with respect to theta is denoted by dy by d theta. Let us try to find out differentiation of this function. B is a constant, keep it as it is. What is derivative of cosec theta? Derivative of cosec theta is minus cosec theta into cot theta. Into what? Cot theta. Let us denote this equation, say by equation number 2. Once these values are known to us, then apply this theorem to find out the differentiation. So we have one theorem that dy upon dx can be written as, yes, according to our theorem, dy upon dx can be written as dy upon d theta divided by dx upon d theta. Both the values are already known to us, and these values we have denoted by equation first and second. Only the remaining part is to substitute this value. dy upon d theta will be equal to minus b cosec theta into cot theta, and dx upon d theta is equal to minus a cosec square theta, so which is equal to minus minus will get what? Cancel. So b upon a, keep it as it is, b upon a as it is. Here we can observe that in the numerator, what is the remaining term? Cot theta, and in the denominator, here after cancelling cosec and one cosec from denominator, remaining term in the denominator will be equal to what? Cosec theta. So which can be here it is possible to simplify it. So let us simplify it. B upon a, keep it as it is. So what is the reciprocal of cosec? Will be equals to sin theta into cot theta. So which is equals to b upon a, keep it as it is, sin theta also as it is, sin theta as it is. Cot can be replaced by what? Cos theta divided by sin theta. Here easily we can observe that sin and sin will get cancelled, and what result we are getting? B upon a into cos theta will be the derivative of the function. तो अब हम क्या कर सकते हैं? एक तो छोटे छोटे अगर फंक्शन है, इजीली हम x एक या दो स्टेप में अगर डिफरेंशिएट कर पाते हैं दोनों भी फंक्शन को, x को और y को, तो डायरेक्टली ये फॉर्मूला लिखो और x y की वैल्यू सब्स्टिट्यूट करो और x की वैल्यू सब्स्टिट्यूट करो, एंड देन डिफरेंशिएट इट, सिंप्लीफाइंग इट, वी विल गेट आवर रिक्वायर्ड रिजल्ट वैल्यू ऑफ dy बाई dx. लेकिन अगर डिफरेंशिएशन, यहाँ पे भी ये सिंपल ही एग्जाम्पल था, लेकिन दूसरी केस अगर इसको 2-3 स्टेप लग रहे हैं हमें डिफरेंशिएट करने के लिए, तो फिर क्या करो? सेपरेट x का डिफरेंशिएशन फाइंड करो, फिर separately y का differentiation find करो, and then write down this theorem, and in this theorem substitute the value of dy by d theta and dx by d theta, and later on simplify it. Isn't it? 2 ways I have introduced. कभी हमेशा ही फंक्शन ऐसे इजी फंक्शन रहेंगे ऐसा कुछ नहीं है, कभी कभी इसे डिफरेंशिएट करने के लिए बहुत सारे स्टेप्स लगते हैं, इस सेकेंड फंक्शन को भी डिफरेंशिएट करने के लिए बहुत सारे स्टेप्स लगते हैं. इन सच केसेस यूज दिस मेथड, फाइंड आउट सेपरेट डिफरेंशिएशन ऑफ x, सेपरेट डिफरेंशिएशन ऑफ y, एंड लेटर ऑन सब्स्टिट्यूट द वैल्यूज इन द फॉर्मूला टू फाइंड आउट डेरिवेटिव ऑफ व्हाट? पैरामेट्रिक फंक्शन. वैल्यू सब्स्टिट्यूट करने के बाद जो कुछ सिंप्लीफिकेशन पार्ट है उतना सिंप्लीफिकेशन पार्ट कंप्लीट करना, एंड यू विल गेट योर रिक्वायर्ड डेरिवेटिव. अगर फंक्शन इजीली डिफरेंशिएट होते जैसे फर्स्ट एग्जांपल में, तो डायरेक्टली पहले फॉर्मूला लिखो और x और y की वैल्यू सब्स्टिट्यूट करो एंड डिफरेंशिएट न्यूमरेटर एंड डिनोमिनेटर, एंड आफ्टर सिंप्लीफाइंग इट यू विल हैव योर रिक्वायर्ड डेरिवेटिव. So I have introduced two methods here. So this method applied if we will get the differentiation of x and y hardly within 1 or 2 steps. Otherwise, use this method. Find out separate differentiation of x, separate differentiation of y, and then substitute the values in our formula to find out derivative. Now see the example number 3rd. Here value of x is equal to under root a square plus m square, and y is equal to log of a square plus m square. So here easily we can observe that directly we are not able to find out the differentiation in one step. 2 or 3 steps are required to find out this differentiation also and this differentiation also, isn't it? आप वैसे फाइंड एक स्टेप में भी कर सकते हैं, बट लेकिन बोर्ड को स्टेप्स चाहिए तो आपको 2-3 स्टेप्स लगेंगे इसका डिफरेंशिएशन फाइंड करने के लिए और इसका. तो हम सेपरेट डिफरेंशिएशन फाइंड कर रहे हैं, x का सेपरेट, y का सेपरेट, एंड लेटर ऑन वी विल सब्स्टिट्यूट दीज वैल्यूज इन द फॉर्मूला. ओके, सो हियर फर्स्ट वी आर कंसीडरिंग x इज इक्वल टू अंडर रूट a स्क्वायर plus m square. Here m is nothing but the parameter, means we have to differentiate it with respect to m. एग्जाम में आपको हर एक एग्जाम्पल में अगर पैरामेट्रिक फंक्शन पे एग्जाम्पल आता है तो वहाँ पे मेंशन होगा that theta is parameter or m is the parameter, isn't it? So here m is the parameter, so we are differentiating it with respect to m, m. So derivative of x with respect to m is denoted by dx upon dm. So on this side, if you'll observe the function, it is in the form of under root f of x. What is the derivative of root f of x? 1 upon 2 root f of x. What is f of x here? A square plus m square into derivative of f of x. What is f of x here? A square plus m square, isn't it? We are differentiating with respect to what? M. Try to understand it. So which is equals to 1 upon 2 under root a square plus m square, keep it as it is. Now here we are differentiating this expression. A is constant term, so its derivative is 0, and derivative of m square will be equals to what? 2m. So 2m into 1 Otherwise, directly say that derivative of this expression will be equals to what? 2m. Derivative of constant term is 0, not necessary to write 0, and derivative of m square is 2m. So 2 and 2 will get cancelled. So m upon under root a square plus m square will be the value of dx by dm. So derivative of x is known to us. Now we are finding differentiation of y. So now consider value of y is equal to log of a square plus m square, isn't it? So differentiate it with respect to m. Differentiate with respect to m. So derivative of y with respect to m is denoted by dy by dm. So let us try to find out its differentiation. To find out differentiation, we have to observe that function is in the form of which standard formula. So here it is in the form of log f of x. What is derivative of log f of x? 1 upon f of x. F of x is here a square plus m square into its derivative, means derivative of a square plus m square, isn't it? So here we can observe that derivative of a square is 0, derivative of m square is 2m, means derivative of this whole expression is equal to 2m, and 2m into 1 will be equals to 2m. 2m upon a square plus m square. Let us denote this value by equation number 2. Once the derivative of x and y is known to us, now use the formula to find out derivative of parametric function. So we have a formula that dy upon dx will be equals to, so dy upon dm divided by dx upon dm, because parameter we have denoted by what? M here. In this example, parameter is denoted by m. So which is equals to, in the numerator substitute the value of dy upon dm. So just now we have got the value of dy upon dm, that is 2m upon a square plus m square, and dx upon dm. What is the value of dx upon dm? Will be m divided by under root a square plus m square. So which is equal to keep this numerator as it is, 2m upon a square plus m square. This term is divided. If you will get multiply, we have to take its reciprocal, a square under root a square m square, a square plus m square divided by m. ये term divided 3 multiply किया तो इसका reciprocal लेना पड़ेगा. Now let us check, is it possible to simplify it? Yes, m and m will get cancelled. So here remaining term is 2, और ये दोनों का division under root a square plus m square and a square plus m square, both the term will get cancelled, and here we will get what? Root a square plus m square. Just we know that x upon or root x upon x will be equals to, here root x as it is रखो. Can I write this x as square of root x? Yes, square of root x will be equal to x. तो x को हम ऐसा लिख सकते हैं. तो एक रूट अगर कैंसिल कर दिया तो क्या होगा हमें? रूट x, and here one root x will get cancelled, so 1 upon root x. So means division of these two term will be 1 upon root x. So simply using this method, if we are simplifying it, it will become under root a square plus m square. Their division will be equal to under root a square plus m square, and this is nothing but value of what? Dy by dx. Now nothing is there to simplify, so that's why we can say that this will be our required differentiation. Now see in the example number 4, given function is x is equal to sin theta and y is equal to tan theta. Here easily we can observe that hardly one step will be required to find out differentiation of sin theta and what? Tan theta. So that's why directly we are writing our formula to find out differentiation. So what is that formula? Dy upon dx is equals to dy upon and dx upon. So here we have to differentiate with respect to parameter. So if you'll observe here, theta is nothing but parameter, because value of x and y both are expressed in terms of theta, means here new variable is theta, and that new variable theta is called as what? Parameter, isn't it? So apply this formula. So now remaining part is just to substitute the value of y and x. What is the value of y? Y is equals to tan theta, and in the denominator dy by d theta, keep it as it is. I'm replacing x by its value. What is the value of x here? Sin theta. So which is equal to, what is derivative of tan theta? Derivative of tan theta will be equals to sec square theta, and derivative of cos sin theta will be equals to what? Cos theta. So in the numerator, keep this sec square theta as it is. What is reciprocal of cos? Reciprocal of cos is what? Sec, and sec into sec square will be equal to what? Sec cube theta. In this way we have got the value of dy by dx, isn't it? Why directly we are substituting the values in this formula? Because hardly within one step we will get the differentiation of y also and what? X also. Otherwise, already I have told, find out separate derivative of y, separate derivative of x, and later on substitute the values in this formula. Getting it? So here also we can observe that within one step we will get the differentiation of y also and x also. Here also we are using same method. So we have the formula that dy upon dx will be equals to, here also parameter is what? Theta. So dy upon d theta divided by dx upon d theta. We are dividing to numerator and denominator by d theta according to this formula, and theta is nothing but parameter. Now just simply substitute the value of y and x. So d by d theta, keep it as it is. What is the value of y here? Value of y is equals to b into theta minus sin theta. Okay, and in the denominator, d by d theta, keep it as it is. Replace x by its value. What is the value of x? A into 1 minus cos theta. Okay, so which is equals to, now we are differentiating it with respect to theta. B is a constant term, so keep it as it is. B, keep it as it is. What is derivative of theta with respect to theta? 1, and derivative of sin theta will be equals to what? Cos theta. Derivative of sin theta is cos theta. In the denominator, A is a constant term, keep it as it is. Derivative of 1 is 0, minus, keep it as it is. Derivative of cos theta will be minus sin theta, isn't it? So which is equals to, in the numerator B, keep it as it is, into 1 minus cos theta also as it is, and in the denominator A, keep it as it is. Minus into minus will become plus, plus sin theta. So differentiation is already completed, remaining part is just to simplify it. So which is equal to B, keep it as it is. According to half angle formula, 1 minus cos theta can be replaced by 2 sin square theta by 2. 2 sin square theta by 2. And in the denominator, A, keep it as it is. This sin theta according to half angle formula can be replaced by 2 sin theta by 2 into cos theta by 2. Just in the numerator and denominator we are applying half angle formula. 2 and 2 will get cancelled. So observe here, in the numerator what is the remaining term? B. ये sin theta by 2 और इसमें से एक sin theta by 2 क्या होगा? Cancel. So after cancelling one sin theta by 2, here remaining term is sin theta by 2. B, keep it as it is. In the denominator, A, keep it as it is, and already sin will get cancelled. Remaining term is cos theta by 2. Cos theta by 2. So here B, keep it as it is. Sin upon cos will be equals to tan. So tan theta by 2. In the denominator, A, keep it as it is. So B upon A, tan theta by 2 is our value of dy by dx. Now observe the example number 6. In this example, value of x is given to us t plus 1 by t raised to power a, and y is a raised to power t plus 1 by t. Here we can observe that we are not able to get the differentiation in one step. That's why first we will find out the derivative of y separately, then derivative of x separately, and later on we will apply our formula to find out derivative of parametric function. Again, it is given to us that a is greater than 0, means a is in the power and whose value is greater than 0, and it is not equal to 1. Why it is not equal to 1? If I am replacing a by what? 1. 1 का power कुछ भी होगा till its value will be equal to what? 1. That's why here they have given that a is not equal to 1 and t is not equal to 0, because t is in the denominator, and if denominator becomes 0, at that time value is undefined. That's why these conditions are given here. So first we are considering y. So here y is equals to a raised to power t plus 1 by t. This is the given function. We are differentiating it with respect to parameter. And what is the parameter here? Parameter is nothing but t. So let us differentiate it with respect to t. So derivative of y with respect to t we are denoting by dy by dt. On this side, function is in the form of a raised to power f of x. What is derivative of a raised to power f of x? A raised to power f of x, where f of x is nothing but t plus 1 by t into log a into derivative of f of x. We are differentiating with respect to t. So here f of x is t plus 1 by t. Just we have applied the formula of a raised to power f of x is a raised to power f of x into log a into derivative of f of x. Now remaining part is just to find out differentiation of this term. So keep this first term a raised to power t plus 1 by t, keep it as it is, into log a also as it is. Here derivative of t will be equals to 1 and derivative of 1 by t is minus 1 upon t square. So let us denote this result say by equation number first, which is nothing but value of dy by dt. Now we are considering x. So and x will be equals to, what is the value of x here? T plus 1 by t raised to power a. Let us differentiate it with respect to t. So differentiate it with respect to t. So derivative of x with respect to t is denoted by dx upon dt. Now we are differentiating this side. So to differentiate it, we have to observe that function is in the form of, which standard formula? So this function is in the form of f of x raised to power n. So first we have to take the power of f of x as an coefficient. What is the power? A. Then decrease its power by 1, t plus 1 by t raised to power a minus 1 into derivative of f of x. What is f of x? T plus 1 by t. Okay, so which is equals to a, keep it as it is, t plus 1 by t raised to power a minus 1 also keep it as it is into derivative of this term. What is derivative of t? 1, and derivative of 1 by t is minus 1 upon t square. We have a formula to find out differentiation of 1 by x. Its derivative is what? Minus 1 upon x square. So derivative of 1 by t is minus 1 upon t square. So nothing is there to simplify. So that's why we can say that this will be the value of dx by dt. Just simply I am denoting it by equation number 2. Now we are finding our required value applying the formula. So what is the formula to find out derivative of parametric function? Dy upon dx is equals to dy upon dt divided by dx upon dt. So in the numerator we are substituting value of dy by dt, where its value is equal to a raised to power t plus 1 by t into log a into 1 minus 1 upon t square. Now in the denominator we are substituting the value of what? Dx by dt. Observe the equation number 2nd. So now we are substituting the value of dx by dt from equation number 2. What is its value? A into t plus 1 by t raised to power a minus 1 into 1 minus 1 upon t square. So here easily we can observe that these two terms will get what? Cancel. In the numerator, observe the numerator, a raised to power t plus 1 by t. A raised to power t plus 1 by t can simply be replaced by y, isn't it? Again this, keep this log a as it is, log a as it is. Already this term is get cancel, means here these are two remaining term, but the first term we are able to denote it by what? Y. Now in the denominator, a keep it as it is, If you observe the denominator, what is the power of t plus 1 by t? A minus 1. Instead of a minus 1, if we are able to convert that power into a, that power into what? A, so that term will be in this form and it can be denoted by what? X. तो ये term को x से denote करने के लिए a minus 1 के जगह पे यहाँ पे power क्या चाहिए? हमें a चाहिए. That's why we are simplifying it, applying laws of exponent. So we know that a raised to power m minus n can be written as what? A raised to power m upon a raised to power n according to laws of exponent. So this expression can be written as t plus 1 upon t raised to power a divided by t plus 1 upon t raised to power 1. Not necessary to write 1 here. A raised to power m minus n can be written as a raised to power n upon a raised to power m. So here, so y into log a, keep it as it is. अब ये टर्म डिवाइडेड है, मल्टीप्लाई किया तो ये टर्म न्यूमरेटर में आ जाएंगी. कौन सी टर्म न्यूमरेटर में आ जाएंगी? t plus 1 by t, t plus 1 by t. And here in the denominator, a keep it as it is, and this whole expression can be replaced by what? X. Replace it by x. Now let us simplify it. Take here cross multiplication and see what we will get. Y into log a. If I am taking here cross multiplication, what we will get? T square plus 1 means 1 plus t square divided by what? T. But that t can be written in the denominator, means a t x, isn't it? After taking here cross multiplication in the denominator, what we will get? T. And that t is nothing in the denominator, so we have written t here in the denominator. And this will be the value of dy by dx. Now see in the example number 7th, value of x is, if you'll observe here, it is inverse trigonometric function, and value of y is also inverse trigonometric function. So now whenever the function is inverse trigonometric function, we have discussed 3-4 types. In one case, we have seen we are able to use the substitution method. If I am replacing t by tan, so it will become 2 tan upon 1 plus tan square, which is nothing but value of sine 2 theta. And here also 1 plus t square appears. Already we have constructed a table in which we have written expressions and substitution. So if 1 plus t square appears, at that time we have seen that substitute t is equals to what? Tan to simplify it. Means in both the cases our substitution is what? T is equal to tan. अगर दोनों भी जगह पे substitution same है तो example और भी easy हो जाता है. So let us see how that example will become easy. लेकिन first function में अगर आपका substitution tan है और second function में आपका substitution sin है तो थोड़े से आपके 3-4 steps बढ़ जाते हैं. Getting it? So in this case, in both the functions, substitution is what? Same. Put t is equals to tan theta. So here we are substituting t is equals to tan theta in both. Put t is equal to tan theta in x and y. Okay, in x also and in y also. So therefore x will become cos inverse of, here we will get 2t, sorry, t I am replacing by what? Tan theta. So 2 tan theta upon 1 plus tan square theta. Similarly, we are substituting t is equal to what? Tan. So y will become sec inverse of under root 1 plus tan square theta. Just simply we have substituted y is equals to what? Tan theta in both x also and in y also. Now let us simplify it. So which will become cos inverse of 2 tan theta upon 1 plus tan square theta. We know that it is the value of what? Sin 2 theta. And here see what we'll get. Y is equal to sec inverse of, what is the value of 1 plus tan square theta will be equals to sec square theta. So in the root what we are getting? Sec square theta, isn't it? So which is equal to, so cos inverse, keep it as it is, sin 2 theta. Here cos inverse is there, that's why we are trying to convert this sin in terms of cos, and we know that sin can be converted in terms of cos applying allied angle formula. So sin theta, this is the value of theta, can be written as cos pi by 2 minus theta. Theta is what here? 2 theta. So we have applied allied angle formula. Cos pi by 2 minus theta is equal to sin theta. So sin theta can be written as cos pi by 2 minus theta, but theta is what here? 2 theta. And on this side, see what we'll get. Y is equal to sec inverse of, sec square outside the root will become sec theta, isn't it? So here, according to our one of the property of inverse trigonometric function, here this cos and cos inverse will get cancelled. So what is the remaining term? Pi by 2 minus 2 theta, and here value of y will be equals to sec inverse and sec will get cancelled, theta. Means we have got the value of x in terms of theta and y also in terms of theta. Now we can consider that value of x is in terms of theta and y is also in terms of theta. So theta can be considered as what? Parameter, isn't it? Now we are differentiating both x and y with respect to theta. So differentiate differentiate both x and y with respect to what? Theta. So derivative of x with respect to theta is dx upon d theta. On this side, derivative of pi by 2 is 0, so not necessary to write 0 here, and derivative of minus 2 theta is minus 2, because derivative of theta is 1 into minus 2 is minus 2, and here derivative of theta will be equals to 1 and derivative of y will be equals to dy upon d theta. Once both the values of dy by d theta and dx by d theta is known to us, we have one formula to find out derivative of parametric function, that dy by dx can be written as dy upon d theta divided by dx upon d theta. Now substitute the value. What is the value of dy by d theta? So dy by d theta is equal to 1 and dx upon d theta will be equals to minus 2. So here this term can be written as minus 1 by 2. Whenever we are writing the fraction in standard form, minus we are writing in the numerator, isn't it? In this way we have got the value of dy by dx. Now we are solving the last example from question number first, that is example number 8. In this case also inverse trigonometric function is there, and easily we can observe that we are able to solve this example applying what? Substitution method. So here, if in the expression 1 minus t square appears, at that time what is our substitution? T is equal to sin theta or cos theta. Means to solve this expression or to convert this expression in terms of tan, our substitution should be t is equal to either sine or cos. We have two choices. Observe the first expression, 4t cube minus 3t. This expression is in the form of triple angle formula. What is the value of cos 3 theta? 4 cos cube theta minus 3 cos theta. Means here we have to substitute t is equal to cos theta, and here we have choice either substitute t is equal to sin theta or cos theta. तो दोनों भी जगह पे substitution अगर सेम आ गया तो हमारा एग्जाम्पल और भी इजी हो जाता है. दैट्स वाई वी आर इन बोथ x and y we are substituting x is equals to cos theta. Getting it? So put x is equals to cos theta in both x and y. So therefore x will become, observe x is equal to cos inverse of 4. I am replacing t by cos theta, so t cube means what? Cos cube theta minus 3. Again I am replacing t by what? Cos theta, and value of y will become, what is the value of y? Y is equal to tan inverse of under root 1 minus, replace t by what? Cos theta. So here we will get 1 minus cos square theta divided by, in the denominator t will get replaced by cos theta. Just simply in x and y we have replaced t by what? Cos theta. Now simplified. So which is equal to cos inverse, keep it as it is. We know that 4 cos cube theta minus 3 cos theta is the value of cos 3 theta according to triple angle formulae. So y is equal to tan inverse, keep it as it is. Let us simplify this expression. 1 minus cos square theta will be equal to what? Sin square theta, and in the denominator cos theta, keep it as it is. Just simply we are applying fundamental identity. 1 minus cos square theta will be equal to what? Sin square theta. Now according to our property of inverse trigonometric function, cos inverse and cos will get eliminated. Remaining term is 3 theta, means 3 theta is the value of x. Now we are trying to find out value of y. Y is equal to tan inverse of, in the numerator sin square theta, outside the root will become sin theta, in the denominator cos theta, keep it as it is. So which is equals to tan inverse of, now sin upon cos will be equals to tan, so tan theta. According to property of inverse trigonometric function, value of tan inverse of tan theta will be equals to theta. So value of y is also known and x is also known, and here we can observe that value of x and y both are in terms of what? Theta. तो यहाँ से हमारा substitution क्या था? x is equal to cos theta implies that theta is equal to cos inverse of x. तो यहाँ पे भी theta की वैल्यू cos inverse of x है, यहाँ पे भी theta की वैल्यू cos inverse of x है, यानी सेम वैल्यू है. And it is possible because in both x and y, substitution is same, isn't it? So in such case, not necessary to substitute the value of x is equal to theta is equal to cos inverse of x. If we are substituting theta is equal to cos inverse of x, and then if we are differentiating, at that time also we will get the same answer. तो एग्जाम्पल इजी बनाने के लिए हम वापस से सब्स्टिट्यूशन नहीं कर रहे यहाँ पे. नाउ वी विल कंसिडर थीटा इज नथिंग बट व्हाट, आवर पैरामीटर, बिकॉज वैल्यू ऑफ x is also in terms of theta and y is also in term of theta, and in both x and y theta is same, cos inverse of x. That's why we are considering theta as our parameter. So now we are differentiate x and y with respect to what, theta. So what is the derivative of x with respect to theta? Will be equals to 3, and derivative of y with respect to theta will be equals to, what is derivative of theta? 1. Once these values are known to us, apply our standard formula to find out differentiation of parametric function. dy upon dx is equals to dy divided by d theta upon dx by d theta. So which is equals to dy upon d theta, its value is equals to 1, and dx upon d theta, its value is equal to 3, means our required derivative is 1 by 3. So here another choice is also there. So now try to understand it also. Now here this is the value of y. What is the value of y? Y is equal to theta. अगर यहाँ पे हमने theta की value substitute कर दी, already example is completed. If I am substituting, let us denote this equation by first and this equation by second. So put y is equal to theta in x is equal to what? 3 theta in this expression. So x will become what? I am replacing theta by what? Y. So here we will get 3y. So which implies that y is equal to, is it 1 by 3x? Yes, it is 1 by 3x. 3 will get divided on this side. So differentiate it with respect to x. So on this side we will get dy by dx, and on this side 1 by 3 is a constant term, derivative of x is 1, so not necessary 1 here. So dy upon dx is equal to 1 by 3, but this is not possible in every case. In this case we are able to substitute y is equal to theta. तो हर एक बार ऐसे कोइंसिडेंटली ऐसा सब्स्टिट्यूशन पॉसिबल नहीं है, तो आपके पास फॉर्मूला भी है, और कुछ केसेस में अगर पॉसिबल है ऑब्जर्विंग द वैल्यू ऑफ एक्स एंड वाई, थीटा अगर यहाँ पे दिखता है और थीटा की वैल्यू आपने वाई सब्स्टिट्यूट कर दी यहाँ पे, सो यू विल गेट one function. Either it will be implicit function or it will be explicit function, and we know how to find out derivative of implicit also and explicit also. So you are able to use this method also till you will get the correct answer. In this way we have completed all the example from question number first. In the next video we will start the question number 2. If you think that these videos are helpful to you, so please like the videos and share these videos with your friends also.